Okay guys, so I wanted to show a derivation for law of cosines. If you're curious, there are so many different ones out there, but I think this one is pretty easy to follow once you get past all the variables that we got going on. Okay, so I'm just drawing an oblique triangle here, a non-right triangle, even though it kind of looks right. And I labeled a bunch of sides. So we're going to kind of start off, if we did any law of sines derivation, I would use the height to kind of connect two angles. So sine of A, I could say, is h over c. And then actually won't need the sine of the other side. I'm going to link this just for law of cosines because we need a cosine. So I'm also going to do cosine of A. And I'm going to need to introduce a new variable for this. I'm going to call it m. And that's just going to be that right triangle on the left side. So equals m over c. So this way we also have values for the height if we want. We know that the height would be equal to c sine of A. And that side m in the triangle would be c times cosine of A. And again, I'm sure there's lots of ways to do this, but much easier kind of knowing what law of cosines look like. But I do a method where it comes from the Pythagorean theorem. So the Pythagorean theorem, I can use that right triangle I have. So I'm going to use the right triangle over here on the right side, and I would have my hypotenuse is a squared equals the height of a triangle plus, it would just be this portion. So in my diagram, b is the whole side, so I'm going to say b minus m. And then I'm going to start throwing in some values we have. So up top, we have that h equals c sine of A squared, and m equals c cosine of A squared. Now our real goal here was to just use the outside values of the triangle. So only A, B, and C and angles. And that's why I have here. I have only A, B, and C, and then two angles. So if I have any of these sides, I could start solving. So let's start just cleaning up what I have. When we write sine squared, we usually put it right next to sine, so it doesn't just look like a squared. And then I have to FOIL over here. And then I'm going to group these terms that have our sine squared and cosine squared. They both have c in front, so I can actually move c out. All right, and we're pretty much at law of cosines. We're going to see later on that this guy, sine squared plus cosine squared, is an identity. I think the easiest way to think about this is in our unit circle, our cosine is usually our y value. Our sine is usually our cosine is usually our x. Our sine is usually our y, and our hypotenuse is 1, so that means using Pythagorean here, sine squared plus cosine squared equals 1. So we'll see that pretty often. So one, iteration, how we say this, format, setup of law of cosines looks like this, where we have all of the sides of our triangle involved, A, B, and C. And then this last term is where we need one of our angles. So cosine of A. So that's one way we could derive law of cosines. Just if you're curious, we're not going to have to do this, but always good to know.